Welcome back, viewers. In this video, we are going to learn about experiment number 9, which is all about exploring the authentication and access control using Radius, TACACS and TACACS Plus. Now, what exactly is TACACS and Radius? Let me quickly give you a brief of this and then we will actually see what we need to implement. To start with, Radius and TACACS are basically what we call as a AAA framework. AAA stands for authentication, authorization, and accounting. So if we want some sort of accounting, authentication, and authorization in our communication, we would like to have either Radius or TACACS Plus installed in our network. What exactly are these two protocols? Let's learn about them in detail. TACACS Plus basically stands for Terminal Access Controller Access Control System, which is basically a Cisco proprietary product. Now, whenever I say Cisco proprietary product, this protocol is applicable only on Cisco devices, Cisco end products, Cisco switches, Cisco client, as well as Cisco server. But whenever I talk about Radius, Radius stands for Remote Access Dial-in User Service. This is an open standard application similar to TACACS, where this particular protocol can be used by multiple vendors which are other than Cisco. So whenever we're talking about Cisco products, we rely on TACACS Plus, and whenever we are talking about non-Cisco products or inter-operating vendors, then we talk about Radius. Okay, one thing to note over here is TACACS is more secure as compared to Radius because TACACS uses TCP port number 49, which makes it a reliable option as compared to Radius. On the other hand, Radius makes use of port number 1812 separately for authentication and 1813 for accounting. Now we'll come back to the similarities. If I talk about the similarities, then the process is exactly same. That is, the process is initiated by a network access device. This network access device, or NAD in short, is similar to a switch. This multi-port switch will first of all get the username and password from the various clients, and then those credentials will be sent to the AAA server. If the AAA server authenticates the user, then something which is what we call as an access accept message will be sent back to the switch, which will be followed by the actual which will be followed by the communication by the client. But if the AAA server sends an access reject message, it simply means that the client is not having proper credentials, and as a result, the access will not be granted. So we can try to correlate this with the KDC protocol or the Kerberos protocol, where there used to happen some sort of authentication. It is quite similar to that, but it takes place with the help of a single server, which is what we call as the AAA server, without the need of complicated symmetric as well as asymmetric encryption involved over here. So this was all about the introduction of what exactly TACACS and Radius is. Let me quickly get back to the Cisco Packet Tracer workspace. So over here, as you can see, we are making use of 3 personal computers, out of which 2 are desktop computers and 1 is a laptop. So in short, these are your clients, and on the right hand side we can see there is the AAA server that we are talking about, and in the middle there is a switch or a multi-port switch. This particular switch is the entry point to our network. So once we have access to the switch, we can do a number of things involving that switch. Okay, so what exactly we want to do is, let me start with the step number 1. Our step number 1 is basically assigning the IP addresses to all the PCs, the switch, and the AAA server. So what we have to do is, we'll start with the AAA server. We click it over here and we go to the desktop, go to IP config and type in all the IP addresses. I've already shown the IP addresses over here, that is 192.168.0.124, and you have to type in the same value over here. The subnet mask will automatically be assigned to it, and press enter. Once it's done, exit it. So we have assigned the IP address to the AAA server. In the similar fashion, we need to go to the switch, click on the switch, and type in all these commands that you can see over here, which is switch spare, then enable. Once you enable it, go to the config mode and type in these commands. These commands are nothing but, first is interface VLAN. As you can see, I am creating a virtual LAN setup over here. I am basically segregating the various LANs in virtual LAN setup so as to avoid any sort of disturbances or any sort of overlapping packets. So I am just considering one virtual LAN over here just for simplicity purpose. You can add multiple virtual LANs if you wish. So the virtual LAN IP address is assigned to this particular switch, and once it's done, just press in no shut and finalize the deal, and just move out of it. The IP address to the switch will be assigned. Once this is done, you have to go to each PC individually, go to desktop, go to ipconfig and type in the IP addresses which are already mentioned over here. And in the same fashion, do the entire process for all the 3 computers. Once this is done, step number 2 is just test the connection by pinging. What happens is, when you click on this PC and you want to test whether it is connected to each and every other PC or not, you simply go to command prompt and you type in ping space the IP. For example, let me test it for the laptop, the 192.168.0.7, and we are immediately getting back a reply. So let me check it for the switch. It is 192.168.0.2. I'm getting a reply from the switch as well, right? So what next happens is, let me try it for the server also, 192.168.0.1. Sorry, I forgot the ping command. Yeah, I'm getting the reply back from the server as well. So this is just a demonstration of my connection is established. You can try it with all the PCs and you will get the same result. So this is all about step number 2, that is testing the connection. Step number 3 is all about configuring the switch. So far we have just connected all the machines with each and every other component. We have not at all configured the authentication. So the very first step is we will be configuring the authentication using TACACS, and then followed by configuring the authorization using TACACS. So first thing is, we now need to go to the switch, press enter. We are inside the switch, and then afterwards you have to type in these commands. First of all, just make sure you are inside the enable mode. So let me just show you. You are inside the enable mode. Now type in config T, and now you can enter these commands. What I am doing is, let me just focus over here. Let me just show it to you what exactly you need to do. These are the steps. First of all, I am mentioning AAA space new model. Now new model is the name of my model, TACACS model, that is whatever I am willing to give it a name as. Then followed by username. This username is nothing but a local username of that TACACS server. So you can give any name. Username space Cisco, password space Cisco. So these are nothing but the local username and passwords of that particular switch, which will be then shared with the TACACS server. Followed by AAA authentication logging Cisco auth group TACACS plus local. Over here, these are the commands. Just this particular thing over here, Cisco auth, which is written in bold, which is written in caps, is the name which I have given. So this is nothing but the authentication which I am creating for this group, that is with the username Cisco and password Cisco. So for this model, that is what we call as new model, I am creating an authentication over here, which is what we call as Cisco auth. So it is nothing but a set of rules called Cisco auth, which I am creating for this new model. Followed by group, followed by TACACS plus space local. Now what is this local thing all about? This local command is written just to make sure if you are not able to connect to the remote TACACS server or the AAA server, then at least the local PCs which are directly connected to the switch may still get access to the switch. Otherwise, what happens if the switch is sending all the information to the AAA server, and if by chance it is not in a position to connect to the AAA server because of some network failure, then what happens? The users on the left hand side will still not get access to the switch. Just to avoid that, we are making use of this command local, just to make sure that the users which are directly connected to the switch will still get access to the features or the services provided by the switch. Clear? Followed by mentioning the host of this TACACS server, that is 192.168.0.1. So it simply means 0.1 is nothing but the IP address of the AAA server. So I'm assigning the IP address of the AAA server to this new model so that it will come to know whom to interact with. And they are sharing a symmetric key which is called as XYZ. XYZ I have given arbitrarily, you can give any number. So it's basically the TACACS server can be connected with the switch with the help of this key only. Any other switch cannot interact with the AAA server because they would need this secure key. Only this TACACS server and the switch are sharing this particular key. Nobody else is knowing this particular key. Next up, we are having this command line space VTY 0,4. Now what exactly VTY is? VTY is basically used to make sure that the users over here on the left hand side are able to contact the switch with the help of telnet commands. Now as we know, telnet commands are basically used for remote access. So for example, we have intentionally shown this laptop over here just to make sure that this laptop wants to connect to the switch remotely, and it can be done with the help of telnet. And to make sure telnet protocol is available, we are making use of this VTY just to create virtual terminals. And 0,4 is simply meaning that we can have at the max 5 connections with the number 0, 1, 2, 3 and 4, right? So after that, we are just saving the model by this particular line, login space authentication Cisco auth. This makes sure that whatever is being written on top before this is finalized, and then we can exit. So this was all about your step number 3. Step number 4 is all about configuring the TACACS on the AAA server. We have so far done all the configuration on the switch. Now it's turn for the AAA server. What to do? We simply need to go to this server, click on the server and go to services. Once you are in services, you need to go to the AAA tab over here. Once you go to AAA, I have already set this up. You simply need to click on this service. It initially will be off, just you have to turn it on. Then you have to type in the client name. Client name is nothing but this particular switch over here. The name of the switch is switch itself. Okay, so type in switch and give the IP address. IP address of the switch is 192.168.0.2. And once you do that, you have to select the server type as TACACS. As we are discussing TACACS over here, we have to select TACACS. In the same fashion, without any changes, you can do this for radius also. As you can see, radius and TACACS are just dependent on the vendor they are using. So we can use the same technique over and over again for radius as well as TACACS. There is no difference over here. So you have to select TACACS in this case and press add. Once that is done, your switch will be shown over here. Similarly, at the bottom, you can see username and password. Username is nothing but the initial username that you had given while setting up this switch. If you remember, that was Cisco and password again was Cisco. So you have to do the same thing over here. Type in the username and password. I can see that and press enter. Once that is done, your AAA server will be configured to accept connections or incoming packets from the switch. So this is the end of step number 4. Step number 5 is all about configuring the switch for authorization, right? So as we know, AAA server is all about authentication, authorization, and access. So we have configured it for authentication. Now we will do it for authorization. If these two are valid, then automatically you will get access, right? So let me configure the switch for authorization. It's a single one-line command which is quite similar to the previous one. It stands for AAA authorization this time instead of authentication space execute. Execute is nothing but I'm allowing the user, once the user is authenticated, I'm allowing the user to execute the exec command. That is, I'm giving the execute privilege to the user, authenticated user, so that once the user is authenticated, he or she can write, read, and execute all the files or all the commands on this particular switch. That is why I'm giving AAA authorization exec default group TACACS plus local. Again, the local keyword is important just to make sure that all your communications are possible even if the AAA server is down, right? Once this is done, step number 6 is your last step, that is initiate a telnet session from any of the PCs. Once your communication is done, once your configuration is done, what you need to do is you need to go to any of these PCs, and now you can start a remote access to the switch, which will be secured using the AAA server. Now what you can do is you can select any PC out of this. Let me select this particular PC, go to command prompt and type in this command, for example telnet space the IP address of the switch. Now as you know, as an end user, I don't have any information about the AAA server. The only thing I know is this particular switch, because I don't know what is happening at the back end of the switch. I am only aware of the switch's presence. So I will have the IP address of the switch, and I won't be having the IP address of any other server attached to the switch. So as a result, I will only enter 192.168.0.2 using telnet. So as you can see, telnet is now applicable on this particular switch. It is asking me for a username. If you remember, we had set the username as Cisco. If I enter it, it will simply give me access to the switch. How is it happening? It's basically happening with the help of the AAA server. Whenever someone tries to attempt a secure shell or a telnet session on this switch, the communication will be forwarded to the AAA server. The AAA server will then send a request message, which will be in terms of username and password. I have to enter my username and password from the client's end. If my username and password are correct, then only I will get access to the switch. So this is what you can see over here. My username and password was correct, so I am an authenticated user, and once I have access to the switch, I can carry out n number of applications, n number of commands on that particular switch. This is the same thing you might have seen with the putty application, putty or putty, whatever you want to call it. Same kind of thing happens over here. So this was all about our experiment number 9, which is exploring authentication and access control using Radius, TACACS and TACACS Plus. So as a case study, I would want you all to kindly do some fiddling with the network, do some changes, add more number of VLANs, and keep on trying with n number of configurations. And if possible, do let me know if you're having any doubts, any suggestions on this particular video. If you like the video, do give a thumbs up, do subscribe to my channel and share it among your friends. Thanks a lot. Stay connected. Stay tuned for the next videos.